What is the true nature of the universe? To answer these questions, humans come up with stories to describe the world. We test our stories and learn what to keep and what to throw away. But the more we learn, the more complicated and weird our stories become. Some of them so much so that it's really hard to know what they're actually about. Just like the string theory, a famous, controversial, and most often misunderstood story about the nature of everything. Why did we come up with it? And is it correct? Or something we should check up? In today's video, we'll go deeply inside this ocean-deep question. Want to join us on the journey to these mysteries of the universe? Then subscribe to our channel and also click on the bell icon for further new notifications. Watch the video till the end. Hope you enjoy watching this video. Then please give it a thumbs up and do share it with other keen learners like you. Now, let's get started. The Heisenberg uncertainty principle, the basis of all quantum physics. So, what does a particle look like then? What is its nature? We don't know. If we look really hard, we can see a blurry sphere of influence, but not the particles themselves. We just know they exist. But if that's the case, how can we do any science with them? We did what humans do and invented a new story. The story of point particle. We decided that we would pretend that this particle is a point in space, and any electron is a point with a certain electric charge and a certain mass, all indistinguishable from each other. This way, physicists could define them and calculate all of their interactions. This is called quantum field theory and solved a lot of problems. All of the standard model of particle physics is built on it, and it predicts lots of things very well. Some quantum properties of the electron, for example, have been tested and are accurate up to 0.000000000002%. So while particles are not really points, by treating them as if they were, we get a pretty good picture of the universe. Not only did this idea advance science, it also led to a lot of real-world technology we use every day. But there's a huge problem. Gravity. In quantum mechanics, all physical forces are carried by certain particles. But according to Einstein's general relativity, gravity is not a force like the others in the universe. The universe is a play. Particles are the actors, but gravity is the stage. To put it simply, gravity is a theory of geometry, the geometry of space-time itself, of distances which we need to describe with absolute precision. But since there is no way to precisely measure things in the quantum world, our story of gravity doesn't work with our story of quantum physics. When physicists try to add gravity to the story by inventing a new particle, their mathematics broke down, and this is a big problem. If gravity to quantum physics and the standard model could go together, we would have the theory of everything. So, very smart people came up with a new story. They asked, what is more complex than a point, a line, or a string? String theory was born. This will be continued. Well, that was all for today's video. We'll meet in the next video. Till then, take care of yourself and bye-bye.